I've mentioned it a few times already, but when we're adding, subtracting, multiplying, and dividing functions, we have to be careful about the function of this, the domain of this new function. And the rule is that the domain of the new function is the intersection of the domain of f and the domain of g. And what the intersection means is that it's the thing that are in both of them. Okay, so if we leave, when we talk about domains, we normally think of leaving things out. If we have to have left anything out of f or g, then we have to leave it out of this new domain. And for f divided by g of x, we also have to leave out any new values that make g of x 0. Okay, so let's start here. We have f of x equals to x plus 2, and g of x is equal to the square root of x plus 5. And we want to find the domain of f plus g of x. Okay, so one thing we could do is look at f plus g of x. F plus g of x, I think this is one we actually did earlier, very similar, would be x plus 2 plus the square root of x plus 5. Now let's talk about this in the intersection way. In the intersection, we know that the domain of f of x is negative infinity to infinity. And if we look at the square root of x plus 5, since it's a root function, to find the domain, we know that we need x plus 5 to be greater than or equal to 0, which means x must be greater than or equal to negative 5. So the domain of g of x is negative 5 to infinity. And so now we want to think about the intersection. And one way we can do this, let's be fancy with different colored pens. Okay, so let's say this is our whole number line from negative infinity to infinity. And let's make the domain of f of x in blue. Okay, so this domain, if I graph it, it would be the whole number line. Okay, the whole thing. Now, if we talk about the domain of g of x, why don't I do that in a different color? I'm going to do that in red. It's everything bigger than negative 5. So it would be negative 5 and including negative 5 and everything bigger. Now, the intersection means everything where both of them are. So here it would be everything where we have the blue line and the red line. And that we can see is actually from negative 5 to infinity. So the domain of this new function, the domain of f plus g of x, is equal to the square root, is equal to negative 5 to infinity, including negative 5. Okay. Now here we have x plus 3 is equal to f of x, and g of x is x plus 2. This asks us to find f divided by g of x and state its domain. So if we have f divided by g of x, we know that's x plus 3 over x plus 2. And individually, for x plus 3 and for x plus 2, both of those, the domain would be all real numbers. But here, now that we're dividing, we have a rational function, and if we plugged something in, it would make the denominator 0. We'd be dividing by 0, and bad things would happen. So we have to say, well, what would make the denominator x plus 2 equal to 0? And if we solve for x, we see that would be x equals negative 2. So that means we need to leave out negative 2. Even though it's in the intersection of both f of x and g of x, since here we're dividing, we get a new denominator. The domain of this function of f divided by g of x will be all numbers except negative 2. I guess this is not an equals, I should do a colon. So it would be negative infinity up to negative 2 union negative 2 to infinity. And I know it's not typed here, but let's do one more example. So let's say we have f of x is equal to the square root of x minus 3, and g of x is equal to x squared minus 16. And let's say we want to find the domain of f divided by g of x. Okay, now the first thing we need to do is we need to think about what is the domain of f of x and g of x. So the domain of f of x, well, again, here we have a square root function, so we'd have to take the radicand, x minus 3, set it greater than or equal to 0, solve for x, so we'd get x has to be greater than or equal to 3. So that would be 3 and everything to infinity. Okay, so we already know for any function that includes f, we couldn't have anything less than 3 in the domain. Now, the domain of g of x, g of x is a polynomial, so the domain of g of x is negative infinity to infinity. Well, we're looking for f divided by g of x. Well, that would be the square root of x minus 3 over x squared minus 16. And we need to be careful about anything that would make the denominator 0. Well, if we set the denominator x squared minus 16 equal to 0, this factors as the difference of squares. So it factors as x minus 4, x plus 4. And if we set each of those factors equal to 0, we'd see that x could not be 4 in our denominator, or x could not be negative 4. Okay, so what we're really saying for our domain is we want them to be not equal to. Well, we already knew that negative 4 couldn't be in our domain because we had already said that our domain couldn't include anything less than 3. So we now also need to leave out 4. So our domain of f divided by g, well, first let me kind of write it out. It's all numbers bigger than 3, well, bigger than or equal to 3, not including 4. So we need to leave out 4. So how we would write this, well, we want to start at 3. So we would go 3 up to 4, parentheses, so we leave out 4, start with 4 again, and go to infinity. So that would be our domain. That's how we would write it. Okay, so if you're just adding, subtracting, or multiplying functions, you want to look at the intersection of the two functions you started with. And if you're dividing, you also need to take into account anything that makes what you're dividing by equal to 0.